Welcome to the Samvaad-Talk by Professor Tricha. She graduated with a master's in integrated master's in electrical engineering from IIT Bombay, and then she did her PhD from Georgia Tech. And she's been with us for about 4 years. She works primarily in security, network, wireless, etc. She's actually been spending quite a bit of time managing our external programs that we offer, the part-time programs, continuing education programs and stuff like that. Particularly the relationship with Upgrad, and she's been brilliantly managing that relationship for the last at least 2-3 years now. And as many of you know, our footprint in terms of the number of external programs we offer has grown phenomenally over the last 2-3 years, and thanks a lot to Tricha for that. So she's been very persistently negotiating with the faculty in IIIT-B who have been involved in this, and of course the institute administration, the deans, the registrar, and the director, and also on the Upgrad side. And managing all the stakeholders is no mean job. She's been doing that phenomenally, and thanks to that, we have a very, very very pervasive sort of footprint in the ongoing programs. So let me invite Professor Tricha for Samvaad-Talk today. Thank you.
Okay, so unfortunately I am not well today, and this is a new topic which actually my students are working on. So both of them are here. I don't want to take credit away from them. So they will be the ones who are presenting. I am here just to give moral support to them for this. So I'll hand over to Priti. Wants to start first? Anjana will start first.
So today, as part of Samvaad-Talk, I, Anjana, and that's Priti, would be explaining the evolution of blockchain, which is the basis for, or which is the fundamental technology behind cryptocurrencies. Okay, so first let's speak into the history of blockchain. So even though the technology of blockchain has been here only since a decade, the building blocks of blockchain, or the fundamental technology behind blockchain, has been there since some time. So first in 1991 was when the blockchain in its raw form was introduced. So it was by Stuart Habers and Scott Stonetter. They proposed the use of a chain of cryptographically secured blocks to preserve the integrity of past information and protect it. Later in 93, the concept of proof of work was introduced, which is the consensus mechanism which is used in blockchain. And then in 2008, as we all know, it was Satoshi Nakamoto who proposed the concept of blockchain as a peer-to-peer electronic cash system. Then in 2009, the first Bitcoin was minted. Then after that, so many other blockchains were introduced, the Ethereum, Hyperledger, and so on. Now, what is the success mantra of blockchain? As we know, it's a disruptive technology now. So it's been used in many other domains other than cryptocurrencies. Now, the success mantra, it's that it's being able to carry out transactions between entities which otherwise do not trust each other without the help of a centralized intermediary in a transparent, immutable, and verifiable manner. So now when we have to do a transaction with a merchant online, whom do we trust? We trust a bank, which is a centralized intermediary. Now the problem is that we don't want a centralized intermediary always. We'll see what are the casualties of centralization. And then the blockchain helps to record all the transactions in a chronological manner, in a transparent, immutable, and verifiable manner. So let me take transparent and verifiable together. So all the transactions, when I say transactions, it's not just financial transaction. What I mean is any communication that's happening between two entities. So any notes, if you're talking in terms of communication network. So these transactions are written in a ledger, which is publicly available to everyone. So it is verifiable and it's transparent. And it's called immutable because you cannot change it once the transaction is recorded in a blockchain. So that's one property which gives security to any transaction. So because nobody can go back and change the transaction even in a future point of time. Now let's see what are the casualties of centralization. So this is something that has happened recently. The citizens of Greece whose money was in a centralized bank in June and July 2015 could only access Euro 60 per day. So it's our money which is there in the bank, and it's the bank who says how much money we can transact per day. So that's a monopoly of power. Again, Chinese Uber drivers were penalized based upon where they drive by their centralized employer. 47,000 Sony employees, social security numbers were stolen, 40 million target customers' credit card information was stolen, and so on. All these happened because the data was centralized and it was with a trusted third party. It was not with us, but it was with somebody else, and it's our data which is getting stolen or being misutilized, or a third party is using their power to control us. So what we actually want is decentralization. When I say decentralization, what I mean is taking the power from the hands of a centralized intermediary and giving it back to the community. That is, if we are the users, the power should lie with us. And if it's my data belongs to me, and I should have all the rights to decide like what has to be done with that data. So for now, you have Facebook and Google and so on. These are all internet giants, as we say. So they get access to our data and they find ways to monetize our data. So we don't know what happens to our data, be it demographic or personal details, which are being used to make money. So if we don't want that to happen, so we should see to it that there is no centralization. Instead, we should move towards decentralization. And then, of course, there are other drawbacks of centralization as a network, like there is single point of failure, there is a lot of traffic more if there is centralization of power. And yeah. So now to the topic, what is blockchain? So I put 3 definitions over there. If you see, there are very subtle differences between all the 3 definitions. This is because we have different types of blockchain. So basically put, it's a set of linearly connected information containing blocks secured with cryptography. Another way of putting it is an immutable and verifiable digital ledger in which transactions are recorded chronologically. A distributable ledger which supports multiple writers who do not trust each other to record the transactions in an immutable, transparent, and verifiable way. So if you have noticed, the difference between the second and the third definition is the word distributed. So remember, a blockchain need not be distributed always. So distributed ledgers don't have to be blockchains, and blockchains don't have to be distributed. But the true power of blockchain technology comes when these 2 things are combined. So then again, there is a controversy happening, like whether something, if it's not distributed, if that should be called as a blockchain or not. The blockchain, as I said, it has different domains it can be used in. But then right now, our focus is on the role of blockchain in IoT. And we are currently working on the security aspect of IoT, so the role of blockchain in security. We are using it for data protection, access control, and so on. Blockchains can also be used for storing and managing large volumes of data produced by the IoT network. And then again, the feature of blockchain called smart contracts, where you can actually put a piece of code into the blockchain and execute and ensure that some policies are being taken care of. It leverages the use of blockchain in IoT. So in short, blockchain offers scalability, privacy, and reliability in an IoT network. So the different types of blockchain, they are the public, private, and the consortium. Public is also known as permissionless. The Bitcoin, which is the popular use case of blockchain, is a public one, or the permissionless one. So as the name suggests, here if you want to be part of the blockchain or part of the Bitcoin, you don't need to get permission from any authority. Anybody who wants to join the network can join, and anybody who wants to add a block to the blockchain can do it, provided you have sufficient computational resources. Nobody will stop you from doing it. So whereas when it comes to private, here there is an authority which says who can join the network. So you need to get approval from an authority before joining the network, or for joining the network. And an intermediate between public and private would be the consortium, or the shared permission, where a group of nodes does all the functionality. Instead of one particular node controlling everything, like in the case of private, in consortium, it's a group of nodes which will be validating or adding the block to the blockchain. So it will have both pros and cons of public as well as private. So public is completely decentralized, where anybody can join and everybody does validating, adding and everything. Whereas in private, it's a kind of centralized, but then you get the other advantages of blockchain like immutability and transparency and so on. And then as consortium. Now the question is, do you, do you actually need a blockchain for your application? So the first question is whether you need a database. That means you have some data to store and you need a database. If it's yes, then if you have multiple writers, even if that is yes, whether the writers are unknown or untrusted or have conflicting interest. So if you have conflicting interest, then you need a blockchain. Or if the case is that you can't rely on a trusted third party. If all the 4 cases hold true or if some of them hold true, then you may need a blockchain. So once you need a blockchain, depending on the access control or the immutability and so on properties that you require, you can use either a public, consortium or private. If you want complete transparency, then you will be going for a public blockchain where there is no much privacy. That means all the transactions are there in the public. Anybody can see the transaction, anybody can verify it. But whereas if you want your blockchain for your some application, it's a test application which is running in your system, so then it's only your computer that's connected to the blockchain, then you go for a private. Or if it's for a company where you don't want to make the data public, it's only a few people who will be seeing or who will be having access to that data, you will be moving towards a consortium blockchain. Now let's look at the first use case of blockchain, which is Bitcoin. Preeti would be explaining that to you. Thank you.
Thank you, Anjana, for giving a nice background about blockchain. So she has already explained permissionless blockchain, and Bitcoin is a classic example of permissionless blockchain. So here we see 1 Bitcoin is equals to 4,68,644 Indian rupees. Why is it so costly? So definitely because of that supply and demand issue. So we won't go into that. That will let our economists deal with that. So I will try to explain the structure of the blockchain, how a transaction works in a blockchain and all. So here, this is a blockchain and how this is a Bitcoin network and how a transaction works. So if someone requests a transaction, it goes to other peers as it is a peer-to-peer network using gossiping protocol, and that transaction is validated. What is the meaning of validation of that transaction? That is whether that transaction is from the owner who claims that it is the owner of that transaction, and for that they check against the digital certificates, and that certificate is generated on the basis of the private key, and where there is any double spending, like the same Bitcoin is being used for another transaction as well. And once this gets validated, a block is created. So what is a block? Block is a collection of transactions. I will come to that in the next slide. And that block is getting added to the blockchain. And once we get confirmations, our transaction is complete. So what is a block? Block is first just not a collection of transactions, but it has a value hash of previous block header, So it is connected in a way. And in what way it is connected? It is storing the hashes of previous blocks. And it is simultaneously it is storing the Merkle root. What is this Merkle root? This Merkle root is the hashes of transactions. So inside a block there will be multiple of transactions. So what we do, we take 2 transactions at a time, we calculate a hash on top of that, and we that way we make a tree, taking 2 transactions, and on the top of that then again taking 2 transactions, And where does our transactions converge? We calculate that hash and we take that as a Merkle rule. So these hashes are the property of blockchain. That's why it is immutable. Since hash has a property, once from the hashes you can't see the input, and there is a fixed output for a particular block. So once it is calculated, it is not going to be changed. This property is being used in blockchain and Bitcoin. That's why it's immutable. How to form a block? Here, as you can see, there is a node. It is listening to other transactions happening in the network and collecting those transactions and making a block. And then it tries to validate, it has already does the validation of those transactions, and then it tries to add that block to the blockchain network. For adding that block to that blockchain network, what does it need to do? It needs to solve a problem using proof of work. Anjana would be explaining that later. And once that block is added to blockchain, we need to wait for confirmations. As we can see that for this transaction, we have got one confirmation. On the top of that block, several other blocks are getting mined. And over the time, as we can see, number of confirmations are going to increase. So how confirmation gives this surety of that this block is going to the part of blockchain.
So now we'll see how the block finally gets added. So every user or every client, as you have seen in the previous, if you remember, if you seen in the previous figure, like they'll be sending out their transactions to the peer-to-peer network. So every validator or every node in the peer-to-peer network would be collecting all the transaction and would be forming a block. Now the question is, whose block has to be added to the blockchain? So this is decided by the consensus mechanism, which has been already studied in detail in distributed computing and so on. So the existing consensus mechanism cannot be used over here because the features or the requirements of blockchains are different. So you have to modify the existing consensus mechanism so that you can apply it over here. So now to the proof of work, which is the consensus mechanism used here. So here what each miner, as we call it, the miner is the node which has the privileges to add a block to the blockchain. It's called a miner because every time it adds a block to the blockchain, it mints a new blockchain, a new Bitcoin is generated. So since a new coin is being generated, this action or this process is called mining, and the node that does it is called a miner. So it's only the miners in the network that has the privilege to add a block into the blockchain. There would be many such miners in the network. So which miner gets to add the block to the blockchain is decided by proof of work. This is just one such consensus mechanism which is being used in Bitcoin. So other blockchains would have other consensus mechanism which we would be seeing. So as Priti was mentioning, a block consists of transactions, the previous block hash, a timestamp, and then something called the nonce. Nonce is nothing but a random number. Now what the duty of miner is to generate a hash such that it is less than a particular value. That value less than what the miner has to generate, that's decided by the protocol. So now to generate the hash, it has to take inputs, the previous block hash, transaction, timestamp, and nonce. The three things, the previous block hash, timestamp, and transaction, they are system defined, and it's only the nonce that is user defined. So it's only by changing the nonce value can it generate different hashes for the same block. So once it's able to find a nonce such that the hash of the block is less than a particular value, then that miner gets a chance to add the block to the blockchain. So as soon as it comes out with a nonce with the with the value less than difficulty, it broadcasts the block that it has generated as well as the nonce to all other validators or miners in the network. So the others in the network can validate whether the actual proof of work has been done, or the nonce or the hash is actually less than this particular difficult value, and if all the transactions are validated. If both the conditions hold true, then that block gets added to the blockchain. The proof of work as a consensus mechanism, it's a reliable one in a non-trusted environment. As we said initially, it's a permissionless blockchain, or it's a public blockchain where anybody can join the network. So how do you ensure that this is happening in a reliable manner? So since proof of work involves a lot of computation power, a node or a miner in the network will not want to waste its energy for adding an invalid block. That's the assumption behind, because a lot of computation resources being wasted. If suppose it's trying to add an invalid block, you are spending a lot of computation energy, and finally the other validators in the network finds out that the block is invalid, then they would drop the block from the blockchain. So the miner is at loss because it has been wasting its energy to get this block added, but finally it doesn't get added because the other validators will not approve of it. Hence, a miner would always try to add only a valid block into the blockchain. The disadvantages of proof of work is that it's highly energy intensive. It has less transaction throughput because in Bitcoin, the policy is that only one block gets added in 10 minutes. Or the difficulty level of that hash is made such that only one block gets created in 10 minutes. Otherwise, there's a problem of double spending, wherein the same coin would be tried to spend in 2 different transactions. So you need to have some time gap so that the same coin does not get spent twice. You need to wait for some time until the transaction happens, it gets confirmed, and then another transaction happens. And then it has high network latency because the transaction has to travel the entire peer-to-peer network, all the validators have to approve, and so on. Now the new requirements of the new applications that are being applied using blockchain are the higher transaction throughput, scalability, performance, and it has to be less energy intensive. That's the reason why we have to come up with new consensus mechanism which is tailor-fit for those applications. So these are some of the consensus. It's not an exhaustive list. These are just some of them. We're just explaining the first few. So the first consensus mechanism, which came as an alternate to proof of work, was the proof of stake. So here you don't have to spend the actual computational resource. Instead, the miner is selected based on the number of cryptocurrencies that you hold or the stake that you have in the system. So the assumption is that if you have more stake in the network, you will not want to make the system unstable. So you will see to it that you behave honestly. You will not do a malicious activity. So that's what is proof of stake. So here what happens is the rich gets richer and the poor gets poorer, because the more cryptocurrencies you have, the higher chances that you get to add the block. So if you are in the network for more time, that means you will be accumulating more cryptocurrencies. That means you will be having more stake in the network. So you get to add the blockchain. So suppose a new node joins the network, it will never ever get a chance to add a block into the blockchain. So then it becomes a kind of centralized system. Hence, there are variations of proof of stake called the delegated proof of stake and leased proof of stake. In delegated, what happens is you don't see how much cryptocurrencies you have. Instead, based on your cryptocurrency, you vote for certain delegates. You get to choose a set of, or like say suppose you have a set of candidates who want to be the miners, and based on your voting power, you can choose who the validator has to be. So suppose I have more cryptocurrency, I have more number of votes to give. And based on the number of votes, one particular node becomes the validator and it gets to add the block. And in leased proof of stake, what happens? Suppose you do not have enough cryptocurrency to become a miner, you can lease your cryptocurrency to others who can compete for the post of miner, and once that node becomes a miner of the network, and if it gets to add a block in the network, it shares the reward between all these nodes. Another one is proof of elapsed time that was proposed by Intel, and it's based on a specialized hardware of Intel. So every node waits for a random interval of time. So whichever node has a shorter interval of time, shorter waiting time, would get to add the block. So this again has a problem of centralization because it's based on the Intel specialized hardware. Likewise, you have proof of activity, proof of authority, and so on, which are the hybrid combinations of proof of work, proof of stake, and with variations. And then you have the consensus mechanism, which can tolerate Byzantine fault also. So I'm not going to the details of all that. The next is permission blockchain, which Preeti would be explaining to you.
We have already seen some drawbacks of permissionless blockchain. So there is a need of permission blockchain. So why is that? So for some enterprise use cases like financial transactions where know your customer and anti-money laundering regulations must be followed, there in such situation you can't allow anybody to join your network. There you must be knowing some identities of the person who are joining their network, and that's what happens in a permission blockchain. So we know identities of each and every person who is joining the network. Then there is a problem of transaction finality in blockchain or in Bitcoin, if we say. So how is that the problem of transaction finality? So as I had shown to you, there were an issue of confirmation. If your transaction is valid and it is like confirmed in a block, then also if you don't get enough number of confirmations, then your then your transaction is not going to be confirmed. So you need to wait for some time and getting enough number of confirmation, then only it will be getting, it will be showing it in your account, right? So for that, achieving instantaneous transaction facility, we go for permission blockchain. And there is a pseudonymity in blockchain, and which is very dangerous. We have a Bitcoin and we go to a coffee shop. We pay them to some Bitcoins. That my address is anonymous, but that guy sees my face. And I go to that coffee shop daily almost. And my identity, he sees my face, I change my address daily, but still there is a pseudonymity, right? And that is not acceptable in many cases. That is a violation of privacy. So that's why we go for permission blockchain, and Anjana has already explained these things: high transaction, low latency, and confidentiality on all. So here, and the risk of participants intentionally introducing malicious code through a smart contract is diminished. Why this happens? Since we know all the persons in our network, if somebody does something wrong, we can ask them, right? Why did you do this thing wrong? And we can go for a governance team that this person is doing something wrong. Then that will create a fear to those persons that you shouldn't be doing anything wrong. But in case of permissionless blockchain, since anybody can join the network, there is no identity, nobody knows anybody, so anybody can do whatever they want. So we are reducing our risks using a permission blockchain. So Quorum is a famous example of permissioned blockchain based on Ethereum. It provides transaction and contract privacy. There is a concept of pluggable consensus protocol, and since we are going for a permission blockchain, there is always a settlement finality instantaneous. I'm not going to go deep into Quorum. I just gave this as an example, and later on I am going to describe Hyperledger. So for talking about pluggable consensus, so far they are using Quorum chain and Raft, and later on they are planning to use these consensus mechanism as well. So Quorum has one public transaction state and one private transaction state. So this public transaction state is not open to the Ethereum public network. It is the transaction network where everybody can, who is the part of that network, is able to see the transactions happening inside the network. But it is not that whatever coins and other thing you are using, you can use directly that in Ethereum public chain. And there is a private transaction state. When we use a filled private for, then we can go for private transaction that is like one-to-one communication. Who are one-to-many communication in the sense whoever is interested in that transaction. It is limited to those parties only. It is not whoever is has already joined the network will be able to see all those transactions. So now coming to Hyperledger. Hyperledger is a Linux Foundation project, and as you can see, there are several companies participating in it. And Hyperledger's first project, Hyperledger Fabric, was introduced by IBM. Earlier, it was working as a IBM Open Blockchain. So, Hyperledger reduces security risk as it limits the transaction to only intended parties, whoever are interested in transaction, rather than displaying the record of transaction to everyone in the network. So I would like to, there are several Hyperledger projects are going on Fabric, Aroha, Sawtooth, and there are some modules which are based on that, such can use these frameworks on the top of that. It's like Composer, it provides more business environment. Instead of going to real coding, we can go to, we can use some high-level language. So there was already Quorum in 2012, and still they are updating their versions. And there was Hyperledger Fabric. It was introduced in 2015. It has a different feature from Quorum, and what is that? It uses high-level programming language. But with Quorum, there was only Solidity in which anybody could program. So if somebody wants to use Quorum, they had to use this Solidity. They had to learn this Solidity. But with Hyperledger Fabric, they provide, they came up with this high-level programming language. And there is a difference of execution, how execution proceeds in how transaction proceeds. What is the transaction flow? That is execute, order, validate. That means a transaction is executed first, then it is being ordered, and then it is validated, and then it is accepted in the network. And in Quorum and other networks, permissionless network, what happens? It is ordered first, then executed, and then validated. So why this execute, order, validate property is beneficial to the users, I will try to explain it to you later. And existence of channel is not known. Channel is used to provide some privacy to the users in Hyperledger. How does this work? I will try to show in coming slides. And in Quorum, they use a filled private for. Once anybody can see that a transaction has this filled private for, they won't be able to see inside this transaction, but they will be knowing that there is some private transaction going on. But in case of channels, the nodes participating in one channel won't be able to know about the existence of other channels. So this is full privacy what they are trying to provide. So this is Hyperledger Fabric architecture. So I will start from the top. This is membership services. Since this is a permission network, everybody needs to have an identity and their certificate such that they can be identified by other nodes. So there is a concept of membership services. So Fabric provides its own CA, certificate authority, as well as external CA. So what does this membership services do? They provide identification to all the nodes in our network. And there is a client and ordering service and peer node. So what does client submits an application to an ordering service for ordering. Before that, it goes to an endorser for execution of that transaction. The whole process I am trying to explain it to you in some next slides. And for now, we can understand that there is a ledger, chain code, events. These are associated with just the peers. These are not associated with the ordering service. This is the ordering service where consensus happen how to order those blocks. So first what we do, endorse, order and validate. What is endorsement? That is execution of a transaction, and then ordering that transaction and that validating and then adding to the network. So why it is a good thing endorsing first? So if there is any inconsistency, if we have assigned some nodes, those should be endorsers of our transaction, and if they are not able to provide the results or whatever the results they are providing, that those are different, then there only we can stop the transaction, and this will reduce the network flows, and latency is also reduced. In what happens in Bitcoin? First of all, it is ordered. We collect, we try to make a block where all the transactions are ordered, and then after we try to execute it and try to send it and make to form a block, and later on if that block doesn't get accepted, so what's the purpose of doing all the transactions and thing? So here in Hyperledger, they first do the ordering, and if that ordering is not they first do execution, and at the execution step only, if they find that there are inconsistent results, then they stop it there. Because the client who is submitting an application, if he is a genuine user, then why would he want to proceed? So in that case, we can, yes sir.
So in Hyperledger, is there any fabric for endorsement policy?
Yeah.
Need not be just majority.
No.
So are there any sort of endorsement mechanism?
Yeah, some policies are already built in smart contract. It depends on the rules, what rules you want. If you want to change color of a car, for example, you want at least these people should agree on that, who are in management group or what. So
you're saying that can be included in the smart contract?
Yeah, that can be. Yeah, that is introduced, or specifically if that is not introduced in the smart contract, then we can specify it explicitly via a channel when a channel is created. Since for each transaction for each group we are maintaining a channel, so when we specify a channel, then we give all these properties, what properties these channels should follow. So what's the first step? Here client proposes a transaction to whom? Endorses. As you can see here, there is an endorsement policy that E0, E1, E2 must sign. And what happens if only E0 and E1 signed and E2 didn't sign? Then if it is a genuine user, then it won't be submitting this transaction further, because he hasn't got enough endorsement as it was supposed to get. Here, all endorsements execute this transaction and send in next step. They send results back to the client with their digital signature, such that client can know that it is coming from the endorsements only. From where we have got this certificate, from the certificate authorities. It could be either Fabric CA, or it could be some external CA. All these modules, ordering service or peer nodes or endorsers or CA mechanism, all are pluggable. So if we, in future, if some better algorithms come, better secure encryption, decryption algorithms come, or certification algorithms come, then we can plug those algorithms at that time. And all these are getting executed in a container, separate container, secure containers. So in fourth step, now when these have already been executed, these are getting submitted to this ordering service. Here this ordering service does the ordering of those transactions. As this ordering service might receive inputs from other transactions as well, from other channels as well, and this person won't be knowing the existence of other channels. That's the privacy of Hyperledger. So for ordering service, there are currently they are using Solo, Kafka, and all. So in Kafka consensus protocols, there is a concept of 3 nodes. First of all, Solo, there is only one ordering node in Solo. It was used for the development purpose only. And for Kafka, there is a requirement of 3 minimum nodes. If there is 1 node, then it's Solo. If there are 2 nodes, then one person will say yes and another person will say no, and it's equal. So we at least need 3 nodes, and there should always be odd number of nodes such that we can reach to a majority. If there will be even number of nodes, 8, 4 on this side, 4 on that side, in that case we might not reach to majority. So we always go for odd number of nodes. Yeah.
Estimate, for example, the lapse time between endorsement and execution in terms of number of endorsements. For example, number of endorsements increase, the lapse time sort of increases exponentially or linearly, something along that.
There is a concept like you in your endorsement policy you have mentioned like E0, E1 and E2 should endorse it, but you are not getting a response from E2. Then you will wait for some time, and then also if you don't get for endorsement, then you can cancel that transaction. Because if that endorsement policy is like these people must have to put a signature on that or execute this transaction. So without that, we can't go any further. And if suppose, like other architecture, if you would have gone for ordering and then after executing, and that time if you weren't able to find that was a wastage of resources. So it is like it is a permission blockchain. It is like a rule, like director must have to sign this, and if they don't sign that, then we can't approve that rule. And once the orderings are done, it is delivered to all the nodes. And on those nodes, they validate the transaction. How do they validate the transaction? First thing, what do they do? Whether these transactions have followed endorsement policies or not. As you would have seen that every endorsement has done execution separately. They didn't know about what the others output. So here we check if it has been asked for all 3 endorsers whether it has got or not. And we check for read and write sets as well. That is kind of double spending. Suppose for example we have a value A, we have a variable A whose which value is 100, and we made a change with that, and that is 50. And these transactions has been submitted to an ordering service, and it is going to that. And in between, only another client tries to modify that value. Okay, so since it has not been reflected in ledger so far, so he won't be knowing that value A has been changed to 50. So that might be a case that he might do a double spending. So in that case, these nodes will check for that read and write sets, which data is being read and which data is being write. And it is on, if client A was doing that first, changes to do value of A, then that will only be accepted. What the other client did later, that will be discarded. And once these transactions are accepted, that these transactions are valid, it is accepted, it is added to the ledger, and all the nodes clients are notified that your transaction has been accepted. So this happens more of instantaneous. What the time it is taking, that how much time endorser is taking to calculate that transaction. Otherwise, it doesn't have to wait for any confirmation. And once it is added to your ledger, then it's added. In Bitcoin, there is a case of fork. So your block is added, your transaction is valid, and later on, if you don't get enough number of confirmation, later on it could be discarded. So here, everything is final. Once it got added, then it got added. And as I was talking about channels, there could be multiple clients and multiple applications running simultaneously on the network. So what happens in case of multiple applications? Suppose E0 is a part of this red channel as well as blue channel, but E1 is not part of the red channel. Then E1 won't even know that there is a blue channel. But in case of quorum, as I was telling you, there is a field that private for. Then there you might know, there you know that some private transaction is going on. But what is inside it, you won't be knowing, but you must be knowing that some private transaction is going on. But in here, in case of Hyperledger, their channels are independent of each other and they aren't aware of each other. So this is a notion of privacy. In Hyperledger, there are other notions of privacy and security as well. So I haven't included them for this slide. Yeah, sure.
So how do we ensure that all the peers will come to the same conclusion on the validation? Because they're checking against, the ordering has already been done. Now the validation is and all the peers have to come in consistently. How do we know that they will come up with the same validation? What if one of them says it's not valid?
Yeah, that's the what consensus mechanism is, like Byzantine fault terrorism. Yeah. Yeah. Ordering is just ordering of transactions.
That also doesn't.
Yeah, that's.
Come up with a consistent ordering.
Yeah, here what happens that they they send their validation to each other nodes, and it's like with enough number of suppose this node got that this is valid from this node, this is valid from this node, this is valid from this node, but this node is saying that this is not valid. So this is only one one thing it is getting that this is not valid, but from other threes it is getting that it's valid. So it goes by majority consensus, so it will add it as a valid block. So that happens.
Somebody new to blockchain, only a very basic question. Somebody kept using the word validate and confirm how it is.
Yes.
And I also understood that the field which you showed is the reverse hashing. That is, blockchains are connected by a reverse hashing. So the actual, I want to touch upon what is the validation process. Suppose somebody initiates a transaction, there's something that he has only Bitcoin available to him, and he wants to buy something. What's the validation? On what information is the validation?
He already has Bitcoins, or he wants to buy a Bitcoin.
You use the word somebody initiated a transaction. I assume the transaction means he's purchasing something online.
Yeah.
That is the case. What information is available in the blockchain for somebody to validate?
There is a public key and private key. So we can sign any transaction with our private key, and that can be validated.
Does the person see? Like the peer is now communicating on the peer-to-peer network. So every peer can participate in the validation. My question is, you also use the word that it's communication intelligence. So my question is, what does the person typically, what does he see? Or is it an invisible code which runs automatically behind the scene, or is there a physical person who sees semantically some information?
Okay, there is a distributed ledger, and there is like more than 100 GB, 110 GB data, where he can track all the transactions.
So
he can,
do it manually?
if he wants, then he can do it. You can use that.
So what information does he see? Physically, what is
Yeah, he can see that.
like he sees the credit rating of the transaction.
He can see the previous transaction. So up to suppose like I perform a transaction, 100 bitcoins have to be transferred to another account. So what the validators who validate if the transaction is possible or not, what they do is they check the Bitcoin up to the transaction where it shows that I have source for 100 Bitcoin. Maybe somebody would have given me in my public address, which is my wallet, if I have sufficient Bitcoins or not. I search for a Merkle root which has this particular transaction. The validator will have to do it. Whoever is creating the block. It's a computer program.
In permission blockchain, there is key value store, and that is all the values you can make a pointer to that, and you can directly go to that. In permission blockchain Hyperledger, they are providing.
Only one kind of result you can get, depending on the credit status of the person. Any validator, regardless of who he is, the peer network, everybody has to come up with the same kind of answer. So there is the notion of consensus, there is the notion of majority. You also mentioned the contribution to be certain numbers.
So like there are millions of nodes connected to the suppose I'm talking about Bitcoin. There are millions of nodes connected to the Bitcoin network. So everybody or majority would be, or some of them would be doing some transaction. So now I as a miner, I can include suppose only 10 transactions in my block, but I get hundreds of transactions at a time. So now I need to decide which transaction has to go into my block. So now that in a Bitcoin, what they do is based on the transaction handling fee. Suppose there's a user who's ready to pay a higher transaction fee, I choose that particular transaction. Or if there is some other validator who's going to form a block, or a full node who's going to form a block, he or that node might have some other criteria for selecting the transaction into its block. So my 10 transaction would be different from the 10 transaction that the other miner holds. So finally, both the miners would compete to solve the puzzle. So I would solve for my block, and the other miner would try to find the hash for that particular block. And whoever is able to come up with the code first or the hash first gets to add the block. So now
there is the notion of just one miner picks up 10 transactions, and several such miners pick up the same transaction.
Possible.
That's the notion of not getting a consensus, because all of them are working on the same ledger data. They all have to create the same answer.
No, it's not necessary that all the miners would come up with the same block. So now I solve the puzzle, and I broadcast it to the peer-to-peer network. So the other validators would check whether all the transactions are valid, whether the proof of work has actually been done, and then includes it in their version of the blockchain.
So my question is, where is the implementation from? Because computer code is ledger data, and it does give the same kind of result over and
no, if this proof of work was not there, suppose two miners come up with the block at the same time. So how do we decide who has to?
There could be malicious nodes as well.
Many times you kept saying that a miner could probably invalidate, and once it's invalidated, it stays in the block, it cannot be removed. Those kind of notions I saw. My concern is if it's a computer code working on a given set of data, there is a notion of the computer code. You can put a malicious computer code. Follows the Bitcoin protocol, but three of us could collude, and the whole system is at the mercy of those kind of malicious code, right? That's the whole point.
So,
how many people will have such code? I understand the
but we assume that more than 50% people are honest. That's the basic. If
suppose there is a malicious user who wants to add an invalid block for some reason. So suppose I'm that malicious user and I added that block. But the other validators in the network will not approve of this node. Just because this is not a valid, because by checking if all the transactions are valid, I would come to know. Probably you call that block as invalid when it has an invalid transaction. Say like suppose somebody didn't have enough money, or there is a double spending transaction which has come into the block or something. Which is a valid invalidation. Yeah. So suppose I have that block and I intentionally add that to the, I intentionally solve the proof of work and then broadcast it to the network. But it is a duty of the other miners to check whether the transactions are valid. So once they find that this particular transaction is invalid, then the block itself is said to be invalid. And I will not add it to my blockchain.
Because so many miners are working on the same ledger data. So the question is, same computer code working on the same data, using the same criteria. What is being added in terms of distribution, in terms of multiple people saying something?
the same copy of blockchain is available with all the nodes. So it is distributed.
You are supposed to use same code. You are supposed to use all of you. But if 49 of you change the code according,
Saying these people who are minors have code savings, they can write a code, they can.
no, they can, that code,
Who authorizes them to even have the code of that kind? I mean, because this is really good currency. It's open right now. Right
it's a soft.
Banking transaction will depend on the bank having employed Infosys to run the software. So you have faith in that. There's a software testing. Now, who is this computer savvy code savvy person who I believe that you really write code?
Since multiple people are doing the validation and all that, so that's why you tend to trust them. So there it's a centralized intermediary, say ICICI Bank, which is doing the verification and all that. But over here, when millions of miners are validating a transaction, and then the data is available with millions of people, and anybody can go and verify whether such a transaction has happened.
What they have is the code they have. Is this something that is from scratch by them, or they supply some code they can give
You download the code. It's an open source code. So if you want to be a miner, you can.
Over and above the template code, they can make some modifications to, for instance, to be malicious to validate a double entry.
And if you don't change the code, you can change the input data. Right? Suppose you asked me, I am a miner, you asked me to validate some transaction that you transfer 100 rupees to somebody, and you didn't have that. That is the input data, 100 rupees. Right? We don't need to change the code, but that input you didn't have that, but I validated that. That's the wrong thing, right? So.
Related question to the hyperlinks. For example, if you have a consortium-based endorsement, basically we are assuming that the endorsers may not have the same objective. That being premised, that we need to have majority endorsement before the order goes through the validation execution.
We need majority.
For example, there is nothing malicious. I mean, it's a controlled environment, right?
Yeah.
It's permission-based. So we don't expect everyone to be there as part of the hyperlinking. So the endorsement is required only because there may be conflicting objectives of the endorsers.
So it is kind of hyperledger, or the admin is facilitating a transaction where some parties who don't trust each other can go for a transaction.
But these,
and we can identify those parties. Yeah, so we trust that admin, right? The other party also trusts that admin, but I don't trust that other party. In that case, it comes into the picture. Sure.
So there must be a cost to the infrastructure, network, and each of the transactions. So how is the cost proportion?
Cost?
Yeah, cost for the infrastructure for the transactions.
It's not centralized. So it's like that it's your decision whether you want to become a miner or not. So whatever resource you are spending, it's from your pocket.
And
when I join as a miner, it's not a sum total of money. Like it's not from one agency who's investing in the entire resource.
And for that you get the transaction fee, and that is pretty high in amount. So nowadays what is happening, they are forming pools. Earlier they were able to mine with GPUs and all, but now that's not the case. So they are forming a pool where there are some ASIC chips and all, so they can mine. So they are investing money into that so that they can get that transaction fee from that.
For every transaction you get a
And
transaction.
apart from transaction fee, there is block mining fee also. But it is assumed that after some time that mining fee won't be there, as those bitcoins are going to be used. But there will always be a transaction fee. Suppose I want my transaction to be faster on the network, so I will be providing more transaction fee. And miners in that way only they choose which transactions I want to consider first. I want to add in my block. That's
One is related to something silly. You mentioned one Bitcoin is 1 lakh something. So does it mean that you can't own fractional Bitcoin? Suppose I want to make a transaction.
Yeah, we can go for fractional. Yeah, fractional.
So the transaction fees are like say 0.25 Bitcoin or something like that. So that's possible.
Second question is I was eagerly waiting for you to comment. The overview is very good, starting from 91 to now. I was waiting for open research problems that you're working on, and my question is are the open problems more on the mathematical modeling side, things like showing latency time or proof of convergence or validation, accuracy, and or is it on the implementation side, or is it on the software side, or the scaling side? I mean, I didn't understand where the research focus is. Your own work is.
So for me, like I'm concentrating on designing an access control using IoT. So there are different devices that are connected to the IoT. So how to decide which node has what privileges in the system, who can read, who can write, or who can access what data, and so on. So the whole policy using smart contract could be written into the blockchain.
Smart contracts has possibility of bugs since it is new. So currently they are introducing bug bounties and bug hunters so that they can come up with some problems for the smart contracts. Because smart contracts is like the engine of that blockchain. That those are the rules. If we change the rule, suppose there is a rule that A1 should be paying 100 rupees to B1 just as a rule. If I change this to B1 should be paying 100 rupees to A1. This is totally reverse, and that's the main thing people target on. And
what are the kind of open source being assets? But one thing I see is in an uncontrolled distributed system, you need automatic checks on whether the whole process is converging. For instance, if we talk about IoT, we have heard about fault tolerance. I mean, things like deadlock, known issues of what happens in operating systems, completely uncontrolled scenario. So are there such issues? I mean,
all the problems that were existing in distributed computing would be applicable over here also. It's actually a merging of so many technologies for distributed computing, the communication as such, say the consensus problem. So it's just that, like, depending on which use case you are applying your blockchain to, accordingly you will have to modify blockchain. Blockchain as such is going to be energy intensive, and a lot of memory is required because everybody, every node which is participating will have to download the entire blockchain. Only then you will be able to verify if some transaction has happened in the past or not. Without that, the whole blockchain would fail. So, depending on what resources you have, or what is the use case, or what is the purpose, you will be modifying. Like, it's being used in the IoT, it can be used in the health, it could be used even for, even in real estate. Suppose you want to buy a property. So instead of having a legal contract written where the lawyer comes and signs and you go through a registration system and all that, you actually register the property in a blockchain, and then you are given a coin or a token which says that you own the property. And tomorrow you want to sell that house to someone, you transfer the token from your address in the blockchain to another address, whoever is buying it. So then you don't want a trusted third party.
For this particular example, so all the different stakeholders will have to be on the Bitcoin.
Yeah, they would be the validators.
or we can change that value to another. If I will take an example of Bitcoin, then we can change it to Indian currency as well. Though in India, our Reserve Bank has banned for that, but there is a method of conversion as well. And there are some
more areas where it's working. One is at the consensus level, traditional distributed computing is trying to make it faster, time to converge on a consensus level still doing. Then there is not now mostly when it has to distribute ledger is open. In a lot of cases where you don't want to put data publicly, so you want some kind of a cryptography. So layers on how you put that and still make it efficient in a distributed system.
So there could be.
There is the level of smart contract sales, the security of the blockchain, proving security of the blockchain. So what concerns I have, for the very same reason you said we should go from centralized to decentralized. And like the centralized system, you can hold somebody responsible for the transaction failed or doesn't go through. Here, when I know I have a valid transaction, I initiated a real estate thing. I know that after waiting those 10 minutes you said, if I wait for enough time, it doesn't go through. Is it possible to trace where things went wrong?
10 minutes is for Bitcoin, and you purposefully do that because there is no double spending. Because but
the
then in the other application, you don't want this 10-minute time. So for example, IoT, you do not want to wait for 10 minutes to get the access. So there it becomes faster.
Whatever we know, there's a cumulative time you have to wait. And at the end of it, you find it didn't go through, the transaction didn't go through. So other mechanisms like toolkits which you can trace back and ask why it didn't go through, because it might have been a valid transaction. For some reason it didn't go through. I mean, what are the traceable
if the
mechanisms?
consensus mechanism does not agree on that particular block, your transaction will not go to the block. But there's a mechanism which ensures that this transaction gets into the very next block.
And especially for Bitcoin, after 72 hours, you can go for read transaction.
There are arbitration mechanisms.
Yeah, like after 72 hours, waiting for 72 hours, you can go for read transaction.
Nobody, no single point is responsible. Who will arbitrate? Who will arbitrate?
Yeah, there are things like network faults, hardware faults, and software faults, and you can't give responsibility to any of them.
We were talking about the various kinds of architectures is there. The architectures by themselves are mathematically shown to be fault tolerant. If something fails, nobody is going to be responsible anyway, because it's just a part of the whole system failing. So how will you identify what went wrong, and how will you ask for arbitration? Because there's no kind of
Okay, yeah. So,
could be anything, but whatever architecture, whatever protocol you're using, what I think the underlying mathematical model doesn't show that, it shows that there's a probability, final probability of something failing. Some particular combinatorial aspect comes up which brings something fail, and you become one transaction becomes contract. How do you deal with it? How do you
it's like there is a
there in the blockchain, so whoever has done the activity, I mean, it's accountable because you get to know that, okay, it is this particular entry that has led to this. So
there are things that why your transaction didn't get confirmed. One is that your transaction wasn't valid. It got discarded by the network. One thing, it was added in a block, but that block became a fork, a hard fork, so it got discarded. And there could be other things that it didn't get distributed to all the peer networks due to some network fault or something. That's why they have given up proof of work they did. They haven't included your transaction in the block they were mining. So you can, there is an option of retransaction that you can do, and by rule everything should be good. Okay.
you told that big list of companies who are doing the calculator fabric. So are there actual B2B, business to business transactions being done in Bitcoin?
Yesterday only Reliance did signed a contract of the blockchain application with HCBC. Yesterday only, Reliance in India they did. Yeah, they are doing.
Not Bitcoin.
Sorry, blockchain, permission blockchain. Yeah. So in business data is like investment, banking data, or health data, or some private data we can't put on an open source. So we go for permission blockchain for those kind of data, especially for enterprise environment. And as I told you yesterday, only they started.
I can just ask one question. The last 2 weeks news of the Bitcoin ATM going into trouble. Is it the ATM which allows you to convert the Bitcoin to currency, real currency?
It was in Bangalore itself, in some mall, I forgot the name, they had launched it, and after that the owner got arrested for that, because RBI has banned in India for the conversion of them. But there was a provision you could have inserted your debit card, and that would have changed it to Bitcoin. But while you were transacting, or you wanted to take some money out of it, then there was like waiting of 2-3 days for confirmation. So, but that is now.
Apart from the Bitcoin, the main theme takeaway is the blockchain is being used widely for distributed storage, for transactions, any other kind of.
So if wherever you don't have trust and if two entities want to transact, you can use blockchain.
So, thank you very much, all of you. Thank you.